Welcome back, everybody. This is Brian and Miss Berlin for Breaking Down Security.
Hello.
Hello. So, Mr. Betcher's not here tonight. It's a Tuesday. We're recording on 1 October. Oh, I forgot. It's Cybersecurity Awareness Month. If you were not aware, you are now aware that it is Cybersecurity Awareness Month. So it's kind of a bit of recursion there. Yeah. What are we going to do this month to celebrate Cybersecurity Awareness Month?
Absolutely nothing.
I think we should do a podcast for 5. I think we should do a podcast for 5. Yeah.
Ta-da!
Educate. Ta-da! Stick the dismount.
Yeah. We're already here.
Yeah. So, we're gonna have a podcast hopefully every week this month, and we're gonna have as many interviews from DerbyCon as we can, like we did last week with Infosec Sherpa, which Miss Berlin missed again. And
I'm so sorry.
Well, I know you got kids. It's the thing. It happens, and it's summertime, and So yeah. And let me see. All right, so we're gonna bring our interview in for the week because we got some stuff. Sorry?
Esteemed guest.
Esteemed guest. Esteemed or esteemed?
Esteemed, yeah.
Esteemed. Okay. Esteemed guest. He spoke at DerbyCon. It was his first DerbyCon, which is what we're going to be talking about because, to be honest, Ms. Berlin and myself, we've seen each other at Seattle because I also need to ask her about DefendCon later, but this was his first Derby, and his last, obviously. So, I'm going to get the name. Oh, God, I'm going to get the name wrong on the back end. Matt, could you just fill in your last name for me, please?
Szymanski.
Oh, okay.
That's pretty
easy. There you go. That's what I was going to go with, but I'm like, nope, not going to try it. Nope, Szymanski. All right. Cool. So you spoke at DerbyCon. Yours was one of the talks that I wanted to make sure I went to because people at my office are doing quite a bit of engagements that employ this technology, and I appreciate you coming and talking at DerbyCon and taking the time. So thank you for coming on the show as well.
Yeah, of course.
All right. So tell people a little bit about yourself, how you got into information security and what you do for a living.
Sure. So right now I run an offensive security team. I have always been interested in security. I've always been interested in getting into the places that I wasn't supposed to be. I started out my career as a developer, kind of worked my way up the ranks. I did a lot of full stack programming. Kind of transitioned into application security, being that I always had that curiosity of, how can we break this thing? How can we take advantage of its intricacies and use them against itself, that kind of thing. So that just kind of morphed over time. And here I am. That's cool. It in a nutshell. Yeah.
Yeah, right on. Okay, so you said you're an offensive security team. Is that different than a pen testing team or a red team type thing?
So,
is there any difference there?
Sure. So we do both. We'll do some kind of red team operations. We do a lot of application pen testing, network pen testing, segmentation testing, some wireless stuff, that kind of thing. All of that kind of falls under the umbrella of offensive security.
Okay. That sounds cool. Yeah.
Yep.
I just learned recently that red teaming and pen testing aren't the same thing because red teaming is you're supposed to be quiet.
Right.
Pen testing is you just run Nmap T5 and pray and spray and pray. So it's just interesting to hear the different terminologies that are out there being used. So
sure.
So you went to your first DerbyCon as a speaker. I did. That's pretty awesome. What did you think about DerbyCon as a whole?
I was blown away. The community is amazing. That was pretty much the biggest takeaway that I got was just how great the community at DerbyCon was. I felt included, and it was my first time. I just had an amazing experience. I'm really disappointed that it was the last year. Also very honored that I got to attend as a speaker on the final year.
That's fantastic. Yeah, we were talking well, there you go. I just
I heard that again.
God.
So did everybody else.
God, I hate that. Fill out your bingo cards, people. I was actually just taking a screenshot of myself because I'm so pretty. I was, I was amazed at the number of people who were there. The fact that we can have that many people in one place and not have any major issues, and the spirit of camaraderie, which I don't think is going to be easily replaced. I'm trying to do that up here in the Pacific Northwest. I'd love to be the DerbyCon of the West Coast, the Infosec Campout, but I don't know. That's a pretty tall order. Dave Kennedy and his Trusted Sec fam put on a great show. So, you're going to be at Texas Cyber Summit in a couple months.
Yeah, the weekend after next. So it's actually October 12th is when I'm speaking.
Okay, all right. So this will be going out hopefully today or tomorrow. So it'll be in about 10 days or so.
Sure.
So if you are at Texas Cyber Summit, go make sure you check out Matt's talk, and we're going to be talking a little bit about his talk here, but you'll be able to talk to him in person. So, Ms. Berlin, do you have any thoughts before we get started?
No.
Okay. All right. So the reason I wanted
lots of thoughts, but I don't know about that are podcast related.
Keep them PG.
Okay.
Anyway, yeah.
Never mind then. I don't have any thoughts.
Okay, cool. All right. So the reason we had you on was my company, Leviathan Security, does a lot of engagements, web-based engagements, and as a PM, I have to do external alignments and I have to talk to the customers and stuff. And some of the questions I get is, what is your technology stack? And the customer will come back and go, well, we're using Heroku and GraphQL, and they're using AWS with RDS and the PG SQLs and blah, blah, blah. And I understand a lot of those acronyms, but GraphQL was one that kind of threw me because I was like, I don't know exactly what that is. And unlike Heroku, where I just found out, we just throw our code up there and it runs it, and I was like, oh, okay, well that's pretty easy. I had to go do some research on GraphQL, and then I found your talk was accepted at Derby, and I was like, yes, I need to make sure I go see that. So I learned quite a bit, even though the audio quality was not the best.
Not the best, yeah.
Definitely want to turn the sound up on that and ignore the buzzing in the background and the feedback. But from what I understand, that's pretty much what happens in a large room. Sometimes when there's not proper grounding. So maybe we could start off at the top and discuss what GraphQL is at a high level.
Sure. So GraphQL is more or less a middleware that sits in between the client and the servers where your code would normally sit. So it was designed to replace REST architecture, where you would normally have to make a lot of different requests to a lot of different endpoints to load all the data that you need into, let's say, an administration dashboard. So GraphQL will allow you to make one single request and get a large amount of data in return by using a query language. So a lot of the benefits of that are decreased latency. So this was created by Facebook and released open source in 2015. Facebook, at the scale that they're running, every millisecond counts. So being able to, send one query and get all the data you need in a nice JSON structure to parse through is a huge win.
Okay. JSON structure, huh? So key pairs, right?
Key values.
Key values. Sorry, not key pairs. Key value. And is it's always structured that way, or are there other ways that it can be rendered?
No, that's the format that it uses out of the box.
All right. So we in our show notes we have a link to slides. Actually, the slides I think that he created in PDF form. You can go and grab those off of our Google Drive and view them. So you can take screenshots and see what's going on. So a lot of companies use GraphQL, including Twitter in this case. There's I can understand the need for what kind of company would use this? I mean, other than Twitter and Facebook being somebody who would make a lot of requests at one time, where does it work best at?
I mean, you can use it anywhere you would use a traditional REST API. Some of the companies that are using this are HackerOne actually has their own GraphQL implementation that is within scope of their own bug bounty program. GitHub uses it extensively for their API. which is a great use case. So in GitHub's case, there's a large array of data that you may want to access, and it's disparate. So using a REST architecture in that case, you're going to have to send a lot of different requests, wait till the responses come back, parse them based on those responses, send more requests to get more data. So being able to query all these disparate kind of, data sources on the back end held in maybe even completely different databases in one query is a perfect use case for GitHub to implement this.
Right.
Because it looks more efficient, right?
Yeah, right. Exactly. It's more efficient, and you can condense everything down to a nice readable structure. The response that you get back is JSON, so it's easy to parse with JavaScript on the front end out of the box. It's a great technology.
So it would, it's all in text, so that means it can be easily compressed as well, and it's fast. So
sure,
it's not a binary format. Okay. All right. So I'm just going down here through some of the slides here. So increased complexity equals more errors. So I'm looking at your architecture slide here, and it's got various different ways how REST works, and it looks overly complicated. There's multiple requests to multiple databases, whereas GraphQL is kind of a single arbitrary kind of connection.
Right. So Google Chrome is going to have to send its request to an endpoint in a traditional REST architecture style. That request is going to be captured on the back end. It's going to do whatever it needs to do to gather that data, and then it's going to send it back to the client.
Right.
In the case of GraphQL, you're going to send a query to that GraphQL endpoint, and then GraphQL is going to parse that query out and pass that information down to resolver functions, which in turn gather the data that you need, just like you would in a traditional REST architecture. But all that data gets passed back up into GraphQL, and it packages it up nicely into one single response and sends it back to the client.
Nice. Okay. I was just thinking out loud here. You talk about we all have problems. There's a new attack surface. You've got docs to read, large complex schemas, reverse engineering schemas to attack, and there's a lack of actual attack tools. Could GraphQL be used for amplification attacks or anything like that?
That's interesting. I'm not sure how you would make that work. Although the schemas can be pretty large, so there could be some way to leverage it in that way. So GitHub's, if you do an introspection query, which we could talk about a little bit later, GitHub will give you its schema back. And I believe its schema is about 84,000 lines long.
Right. Okay. Yeah, I mean, amplification attacks, obviously you need a lot of, GraphQL implementations that have introspection running with a large amount of lines. But I guess it wouldn't be the best for necessary amplification attacks. You can tell me if I'm wrong or if I'm full of crap. I don't come into this prepared in any way, shape, or form. The questions I'm asking is not just like questions that people on the podcast would know. So when you mention attack surface, it's just an API, right? So how is it a new attack surface?
Well, it's new in the sense that a lot of people don't understand what they're dealing with when they run into it. So my first kind of foray into GraphQL was when I was playing around on Hack the Box. And one of the boxes on there, I did all my enumeration and all that, and there was a port open, port 80. So I checked it out, and it was an Express application that had this really kind of strange interface. And it took me a while to kind of figure out that I had to send it this specially shaped request to start getting responses back. And from there, I kind of figured out that, there's this thing called an introspection query. And then there's this, that I can do that, and it'll tell me the schema. Then I can start breaking that down and sending more narrowed requests to get the data that I want out. And I started kind of just poking around and asking people that I knew. And most people had never even heard of it before. So I thought, there's got to be a lot of stuff out there using this if it's on a Hack the Box.
Right.
So I ended up finding out that there's tons of companies out there using this technology. And perhaps when during an engagement, they think they may actually be dealing with a REST API because there's no dead set giveaway. It could easily be a REST API that accepts a JSON request and returns a JSON response. So there could be a lot of stuff behind there that they don't know that they're actually missing, which means you're not doing the engagement to the full potential that it could be done. So I'm really just trying to bring awareness that, this exists out here. Here's some good methodologies to use to test it so that we can make the internet a safer place.
Right. Okay. So the API, the GraphQL has a specific format. Is it the same format for regardless of the implementation, or can you have different? Fields, or can you have different structures inside of the GraphQL implementation?
So you create the schema on the back end using a type system that you can define for whatever data structures that you have. So it's fully customizable to however your existing backend data looks. There's no real default out of the box. You have to use this particular schema, which gives it a huge amount of flexibility as well. So it's another great advantage of using GraphQL is that flexibility that it gives you.
Right. And I don't know, to equate it, it would be like a schema is like a style sheet for an HTML file or an XSL file for XML to render it or to give you an idea of what the data structure is.
If you ever worked with a SOAP API at all, this is similar to a WSDL file where I send it there. The schema is basically, here's all of the objects and fields and some descriptions of those fields and what's in there that you have access to by sending queries, right? So it's, okay. I guess you could kind of loosely attribute it to if you were to dump all of the tables from a SQL database and look at all the different columns in each table, that's how you're going to know what's available for you to query against.
Right. Okay. All right. That's cool.
Is the implementation of it like by default insecure? Like, are there any?
So that's the thing is there's nothing actually wrong with GraphQL itself that I've been able to find. It's how the code is implemented on the other side of the GraphQL implementation that people don't maybe understand as they're implementing it, that out of the box, there is no authorization or authentication system built into it, right? Okay. So all of that's just left up to developers to figure out how to do. A lot of the server implementations have solutions for this built in, but again, they have to understand them and how to implement them correctly so that it's actually secure.
So no authorization or authentication. So they're just hoping that developers will be able to call that properly.
Sure.
Yeah, that sounds like it might be kind of a problem there, or
sure.
Because all you need to do is get the right user, and you can, query whatever you want whenever you want. So
sure, yeah.
Right on. Okay.
And there's the ever-present battle between the business wanting to move fast and hurry up and implement features, and so these developers are under pressure to get these features rolled out across each sprint. There may not be enough time in that particular organization to really understand this new technology to the level that they need to, especially with deeply nested schema structures or extremely complex data structures on the back end. It can be easy to miss things.
Can you give me an example of what an extremely complex data structure would be? It's all text, right?
It's all text, but something I've found interesting and had work occasionally is, let's say you have an object with some nested fields. Well, one of the neat features of GraphQL, if you've ever done any programming, you can kind of compare this to how an object in an object-oriented language works is I can have an object and then a bunch of parameters, but one of those parameters can also be another object. So that's the same thing in GraphQL. I can have an object with a bunch of fields, but one of those fields can also be another object. And then under that object, I can have more fields. And then under those fields can actually be an object. So if you have that can just basically go out. It's I don't know if there's a limit to it, a technical limit to it. But I've seen some pretty deeply complex ones, especially with extremely large schemas like GitHub.
Can you cause any kind of loop or any kind of infinite loop logic?
Yep.
Okay.
So if there's some circular reference going on in there, you can actually craft a deeply nested circular reference request and send it. And if there's no stopgap in place for that, you could basically DOS that system doing that.
Through resource exhaustion or memory exhaustion? Okay.
Yep.
Right on.
And if you have that, auto scaling out automatically and hooked up to somebody's credit card.
Yeah, that could be bad. That could be bad. Okay. All right. And so we're talking about objects. You can query other nested fields. We know to expect an array instead of a string. So what is it? It's so you can set an array looks like, so you have friends and then you have everything's in brackets or braces. And
right. So on the schema side, on the back, when you're actually defining what your schema is, one of the ways that you do that is you can denote that something is going to return a list of objects by wrapping it in brackets.
Mm-hmm.
So as you're reading through the schema from a not evil point of view, like, sometimes companies want to keep their schema available to everybody so that people can integrate with their product set. So as you're reading through this schema, it's pretty easy to determine what type you're going to get back when you do a query based on how the schema is written.
Right. Okay. So yeah, one of the other things I saw during the talk was you mentioned scalars quite a bit. What is a scalar exactly?
So a scalar is kind of like a primitive. So it's going to be like a string or integer or something like that.
So it just defines what the value is going to be that you're about to get?
Yeah, what type the value is going to be, right?
Okay. So type. So you've got object types and you have object strings, but the only real difference is that there's no period. Okay, I see what we're talking. Okay. So yeah, you're definitely gonna have to get the slides. There's some discussions on what types are. It talks about scalar types. So you have non-nullable scalars values,
sure.
or
so
arrays?
If there's an exclamation point next to the type declaration, that means that you can always expect a result back because it's basically a required field at that point.
Mm-hmm.
Now, the interesting thing about scalars is it comes with some prepackaged scalars for you to use out of the box, all the basic stuff. But it also has the flexibility to let you implement your own custom scalar types. And when you do that, like let's say JSON, right? You have to implement your own validation logic for that also. So that's another area where if you're reading through a schema and you notice that, hey, this field has a scalar type that's non-default, maybe you want to poke a little bit harder at that to see if you can bypass their validation logic on that because it's going to be custom.
Right. Okay. I'm looking up something here. So one of the other things that I saw when you were in your slides, you mentioned defines how the type should be serialized, deserialized, and validated. So there were, I don't know, about a year and a half ago, there were a bunch of vulnerabilities dealing with Java deserialization.
Sure.
Does this also suffer from that kind of issue? So
I guess that would depend on the actual GraphQL server implementation itself and what methods it's using to deserialize the data. But serialization and deserialization vulnerabilities are not new. They've been around for a long time. They continue to find them because serializing and deserializing thing is a complex process. And anytime there's something complex, there's, higher chance of you finding a vulnerability in it.
Right. And deserializing data in this case, maybe you could explain that to me as why that's a vulnerability?
Yeah, so it can get kind of complex, but in a nutshell, serializing is changing it into a format that can be more easily transmitted, right? So when it gets onto the back end, it's got to unpack that data back into its original format or into some kind of format that particular backend application can read. Maybe it's a native object of that particular type of programming language. So when you do that, you can get some weird stuff happening, and there's a lot going on in there the way that happens. So you never know what you might be able to inject that when it tries to actually change that format back, triggers something else, an execution flow to happen that wasn't intended.
Right. I mean, obviously, with all this text and the schemas deciding what is a valid scalar type or whatever. Input validation. Would we see things like typical OWASP vulnerabilities in this, like cross-site scripting, cross-site request forgery? Would we see any of that kind of stuff in this?
So that would be kind of outside of the scope of those two particularly would be a little bit outside of the scope of the GraphQL, but you could use a cross-site request forgery vulnerability to trigger a GraphQL query. And maybe get data back that you weren't intended, since you're kind of sending a request that you're not supposed to be able to send using CSRF. But XSS would exist mostly in the browser, but SQL injection, NoSQL injection, command injection, all of these still exist, right? Because if let's say I pass a parameter, let's say I make a query for a hero, and I don't just want all the heroes. I want a particular hero. So I'm going to pass an ID in. I'm going to say I want hero with the ID 1000. So that query parameter that I pass into, that argument gets passed into GraphQL and then blindly passed down through the resolver into the resolver function, which could be pretty much any programming language. You just don't know. So all of those traditional type attacks where I can pass in user data and have it do some funny business on the server side could still be there. You just have to know how to craft the request so that you can pass it down through the resolver functions.
Yeah, I see here in your slides you were also talking about potentially indirect object reference for the IDs or what have you. If you could enumerate those in some way, that might make it easy to make a query and pull any additional data. So it'd be be basically insert or grab all the files in the database, for instance, or grab all the data in the API. So
sure, that would be a lot of like SQL injection. But like for IDOR, if you're testing this stuff and you see it passing an ID, enumerate the ID, see what other IDs you can pass in there, and perhaps you can, it'll think that you're somebody else because the authorization logic on the back end isn't implemented correctly, or tied to your cookie or what have you. Yep.
Okay.
Is there an HTTPS version too, like there is for APIs?
So that way. You could implement it non-HTTPS. GraphQL is kind of independent of that. It kind of, you could, I'm sure, figure out a way to set up a server using non-HTTPS. It's all on how you configure it. But that's going to be up to the actual server implementation itself. So
gotcha.
If it's all up to them. That's the huge flexibility with this. Is that basically everything except schema and passing data resolver functions? That's what GraphQL does. So anything outside of that is just left up to the developers to do what developers do.
Right on. Ms. Berlin's probably asking because she deals with a SIM and some logs all day. So if she can figure out a better and more efficient way of pulling logs and querying them, I think that would probably be a good idea.
So if she's dealing with graph databases and things like that, this could be an excellent way to request large amounts of disparate data from that system and have it all handed back in one single request. This technology is excellent if you're trying to implement some kind of administration interface where you have to, gather a lot of data, and then on the front end it's being parsed into, JavaScript charts and this kind of all this kind of stuff. That's exactly what this was kind of made for.
I see. And it works with you said at least with like NoSQL database, but I'm assuming it works with any database, even Oracle or.
It's completely up to you. So however you decide you want to write these resolver functions, it's GraphQL is basically going to say, this is what the person wants, and here's the arguments that they send along with it. And it's up to you to implement how that data is actually retrieved from wherever you're storing it at and passed back up.
Right. Would you still want to use something like, prepared statements in those to keep the chances of
absolutely
SQL? Okay.
Yeah. All right. Absolutely.
And does it matter where the queries go? Do they have to go at the top of the GraphQL? I mean, where does the query end up in the structure here?
So
is it opened in a different way, or how does that happen?
So GraphQL itself accepts a query. It kind of has its own JSON query language per se. So you're basically going to send it a JSON shaped request asking for what you want, and that is the GraphQL query. It's going to take that, and let's go back to the hero example from earlier. Right. It's going to look up and say, okay, where's the resolver function that gets heroes from wherever? And it's going to say, and it's going to pass your argument down to that resolver function. So to do it right, you would take that argument that's been passed in, sanitize and validate it like you would in a secure application, pass it into a parameterized query that is, talks to the heroes SQL database in the back end. And it's going to get that hero with that particular ID, and then it's going to hand it back to GraphQL, which is in turn going to pass it and package it all back up with everything else that you asked for and hand it back to the client, which would be your browser usually.
Okay. All right. And I can understand how powerful this is, because if all the humans were in one database and, all of the you put in Luke Skywalker, for instance. So if all the human names are in one database and all the heights are in another database and, all the villains are in a third database, you can query all of them from 3 separate and disparate databases and pull that information. You don't have to do even database normalization or anything like that to pull all that out.
Or let's say you have a public schema and you also have a private secret schema, right? You don't ever have to hook a different API endpoint up to a secret schema for people that are logged in or something like that. Whatever your implementation may be, you'll be able to get all of that within the resolver functions and hand it all right back. So,
okay. So that's question. You mentioned a public and a private schema. Can there be, is public and private the only ones that are available? Because you said that there were no authentication and authorization.
So the GraphQL schema isn't public and private. What I meant was, like, let's say, for instance, HackerOne, one of their vulnerability, they had a SQL injection vulnerability in one of their resolver functions. And somebody was able to pass in a SQL injection attack payload into their request, and that got passed down to the resolver function and allowed them access to HackerOne's public database schema, which is basically, we're going to put everything that it's okay for people to know in this schema, and we're going to put all of our secret stuff that you need special authorization logic and stuff to get to in the private schema, let's say. That's how they would that's a good way to segregate your data so that you don't accidentally cross-contaminate, sensitive information in with data that is not necessarily sensitive information.
Right.
But that all shares one the GraphQL schema, however they defined it, and however they pointed different objects and fields to resolver functions, is completely independent of that.
Right. It sounds like you could use the schemas as an authorization boundary by having different ones. So if Bob logs in, he only gains access to the Bob schema. If Bill logs in, he'd gain access to the Bill schema, and he's Bob's boss, so he'd access Bob's schema as well. Does it work? Can it work like that?
You could, but that probably wouldn't be good architecture design, because every time you had a new user sign up, you'd have to spin them up a new database table.
I see.
But
Okay.
but you could do that, but that you'd still have to have some logic in there to say, oh, this is Bob, right? So if I'm able to break that logic, now I'm able to access everybody's schema.
Right. So when you would do the authorization and authentication, you obviously can't do it on the GraphQL. Would you have to set the security controls on the databases that had the information, or in I mean, the controls have got to be somewhere, right?
Sure. So that they would kind of sit in between. They would sit maybe in the resolver functions. So the resolver functions are going to be kind of your own custom code that sits. So there's client, and then the next phase would be the GraphQL endpoint, and that would lead down to the resolver functions. And that layer would be your own custom code that developers wrote to do any kind of database fetching, authorization, authentication logic, validation, sanitization, hopefully. All of that's going to sit there in that custom code.
I see. Okay. And that,
right. So that's really what we're attacking here is that layer of custom code. And we're using GraphQL as a, carrier mechanism to hand off our malicious payloads to that custom code.
Right. That makes sense. I was pulling up, looking up for the resolver stuff, and I found a website, Apollo GraphQL. Looks like everybody's trying to make their own. So I guess.
Yeah, there's quite a few implementations out there.
Right. Okay. Let me see. All right. Sorry, I'm going down the rabbit hole.
Was your first vuln that you found on this the beer one?
So when you say found, was that wasn't me in particular that found that vulnerability? Okay. Yeah.
Okay. Yeah. All right. I thought that was pretty interesting. I'm like, that would be a pretty cool.
It would be excellent to find that. I'd be pretty proud of myself. Yeah, they should be pretty proud of themselves for finding that. It was pretty clever.
And that was it for part 1 of our discussion with Matt Szymanski on GraphQL. You can find him on Twitter at RVRSHELL, reverse shell, RVRSHELL. Miss Berlin, of course, you can find her on Twitter at InfoSystir, INFOSYSTIR. She's also very active on our Slack, which you can access and join by sending us an email to our official podcast email, bds.podcast@gmail.com, or you can hit up our Twitter at Brakesec, BRAKESEC. I am on Twitter as Brian Brake, BRYANBRAKE, and Mr. Betcher, you can find him at Betcherpwned, BOETTCHERPWNED. He also has a software product called LogMD, which is a forensic tool that sets up your Windows machines to ensure you're getting proper logs, which will help you analyze malware, look for artifacts that can lead to potential incident response problems. And it's free. It's a freemium model. So if you want additional product or options, there's also a paid version. So you can check that out at log-md.com. Some exciting things going on. Brakesec has a class coming up starting on the 2nd of November. It'll be an online course with Nicholas or NXVL on Twitter. You can join us. Python course is learning how to secure Python. We released a video, which you can find in our show notes on YouTube, about a 10-minute video with myself and Nicholas sitting down and discussing what the class is going to be about. Nicholas lives in Lima, Peru. So we're planning on doing it on a Saturday morning Pacific time, about 8:30 in the morning. Which will allow pretty much everybody except, unfortunately, the Asia Pacific region. But we're not recording this, so I'm hoping that Nicholas will be able to do another class, say an evening class for us, which would allow the rest of the world to get a hold of it. If you're interested, you can go to brakesec.com/Brakesec Python class. That's all one word, brakesec.com/Brakesec Python class. Also, before we go, I'd like to send some appreciation to some new Patreon supporters, Josh P. and David G. Thank you for donating to our Patreon. They are helping us with just the time and effort to build a community. They help us pay for our Zoom and hosting fees each month, as well as making sure that we can continue putting out the podcast on a weekly basis. So I appreciate Josh and David for doing that. We also have a TPub if you don't want to sign up for a Patreon or a PayPal to send us any tips. You can go to tpublic.com/user/bds.podcast and buy a t-shirt. You can get one with Brakesec logo on it, or you can get one of the recent conference we did, the Infosec Campout. We actually still have the t-shirt with Miss Berlin's face on it. So, which, as you'll hear in part 2, there's an update to that story. So, Amanda will be at the Texas Cyber Career Summit. So you can go to cybercareersummit.com. She'll also be keynoting at GrrCon on October 24th and 25th. And Matt also mentions that he's going to be at the Texas Cyber Summit. If that's not in part 1, it will be in part 2. Texas Cyber Summit, which is going to be in a couple weeks. So if you're interested in seeing him talk about GraphQL in person, or you want to pick his brain, you can go to Texas Cyber Summit's website and Google that and find that. So that was it. Thanks for breaking down security this week. Part 2 coming up, we'll discuss attack techniques. We'll talk about specific implementations of GraphQL. There's a fairly well-known e-commerce website out there that uses GraphQL. So we discuss all of that. We also discuss Matt's tool called Shapeshifter and how it works. And you can find that in the show notes if you want to go and grab that early and take a peek at it. Also, his slides are in there as a PDF on our Google Drive. You can view them, which also means you can download them as well, I would imagine. So yeah, that was it. Have a great week. Be nice to one another. Take care of yourselves, because you're only you have. And we'll talk to you again soon. Hello, everybody. This is Brian from Breaking Down Security. This week is part 2 of our interview with Matt Szymanski, RVR Shell on Twitter, which you'll find out again at the end of the show. This week we're going to talk about when you're doing pen tests, how you would find, whether or not it's a GraphQL type API, ways to protect and defend against potential attackers. What you'll find is that some of the controls in place aren't going to stop them for long, and it really only takes them out a good bit of time to suss out your schema. But you'll need to add additional controls on top of the ones ingrained into GraphQL to be able to protect against it. So we're going to go ahead and get started. If you have any questions, feel free to reach out to the show. We'll give you contact information on the back end of this podcast. Also, there'll be a link in the show notes to our Eventbrite, which is Nicholas is doing a class for secure Python coding. So feel free to sign up if you are wanting to get information and learn how to code or protect your Python applications. So you can find out more about that by clicking on the Eventbrite link in our show notes. So have a great week. So one of the things that I hopefully my testers and consultants are listening to this, because we are seeing a lot more of these kinds of not typical web architectures. I mean, they're getting more typical, but sometimes we get thrown curveballs like this. How would we know when we you said you discovered it first and hacked the box? What would be some indicators that, let's say, customer doesn't want to tell you what their architecture stack is. It's completely black box. You're walking in completely blind. Here's a website. How can they tell if it's a GraphQL implementation? Will it say it in the schemas? Should they try an introspection query if they see a REST API just because, it may actually work? Or what are you looking at?
Yep. So there are some little kind of hints. Typically, in the URL, you'll see the domain name, and then you'll see a query parameter, a URL parameter called query equals. And if you see query equals, I had never really seen that before in any kind of REST API architecture. And typically, you get the prettified URLs. It's like user/1/ name or something like that. So when you see that query equals, that's kind of a hint that you might be dealing with a GraphQL implementation. Try sending it an introspection query. That's a great way to find out, because it's typically, even if they have introspection disabled, which you have to do, it comes default turned on. So if they just didn't disable it, they didn't even realize that they should disable it, which it's not necessarily bad to have it enabled, but if your goal isn't to share your schema with everybody, then you have a closed source product, you have your own website, like a SaaS product or something like that, and you're not necessarily, it's not a software as a service, there's really no good reason to have introspection on. But either way, you're either going to get back, typically, introspection is disabled or not allowed. So well, hey, I'm still dealing with GraphQL here, because it's telling me that introspection is disabled. Or you're going to get a huge, big old fat blob of text back that is the schema itself.
Okay. And I'm assuming at this point, Burp Suite or some kind of web interception proxy is your friend?
Yeah. So there's a lot of different, what they call GraphQL consoles out there. And they're basically either a web application or a browser extension, or a standalone bundled as an Electron app that lets you send queries to GraphQL endpoints and manage them. And it has like whole tabbed interface and all this really nice fancy stuff. And it will automatically in the background send an introspection query when you set the GraphQL endpoint in the system, and it will parse that introspection query and build dynamic documentation from it, which is another really great feature of GraphQL. You can build descriptions for each of your fields and objects right into the schema and build dynamic documentation about your API from it. Right.
Okay, so that makes sense, because we were on an engagement, I won't tell you the company, but they had mentioned something called Graphical. And
that's one of the most common consoles out there.
Right. It's an IDE from GraphQL, itself, and it's an in-browser IDE for exploring GraphQL. So that's pretty cool. And so you can use this to do testing with. I would assume are there additional plugins for this, or is this kind of a one size fits all?
It's kind of there's a bunch of different ones. They all more or less do the same thing. They just have slightly different interfaces and how to use them. I'm sure that there's technical differences on the back end. I haven't dug that deep into how the consoles actually work. They're mainly just JavaScript applications. But they, at the end of the day, they're all pretty much going to do the same thing. It's probably going to be down to personal preference, which one you want to use due to some specific feature set.
Right. You also mentioned in your talk specific endpoints that you could call. You mentioned graphical, GraphQL, GraphQL.php, GraphQL/console. These are pretty much just default endpoints. So I know we don't preach security by obscurity here. We actually had a show about it, but that would be something you would want to change if you're using graphical or GraphQL in your environment, to change the endpoint names?
Well, you could, but it's going to be pretty easy to find if you have a front end hooked up to it, right? Because I'm just going to monitor the network tab of Chrome, would be the simplest way to do it, and just see where the front end is making calls to. But if it does, let's say it's a software, it's an API only, it has no front end built into it, then you're going to have to maybe do some searching to find what the, I know company XYZ has this. I hope there's not a company called XYZ out there. You might have to try a bunch of different endpoints. And, as an example, GitHub's is located at developer.github.com/v4/explorer. So
okay,
it could be any one of different versions. It could have a subdomain there. It could have it. You could make it completely custom yourself. So of course, the first thing you got to do is actually find that endpoint. So you're going to want to use like WFuzz or AltDNS or shameless plug. The tool that I wrote will automatically search for all the ones basically listed in here to do that with. It's just going to basically enumerate through, try and find a correct response, and then hook onto that when it does find a GraphQL, either a console or the actual endpoint itself, because the console is going to be located at a different URL than the endpoint itself. If you run across the console, you're going to have to, use burp or open up Chrome Inspector, Network tab, and send some requests to see where the actual console is talking to.
So you mean to tell me with all this new web technology, we're still using things like Dirbuster to find endpoints?
Because at the end of the day, it's just different implementations of the same thing. Right? Right.
Okay.
We have all this fancy technology. It still sits at a URL somewhere, right? So we can still use the tried and true enumeration techniques to try and find what we're looking for.
Yeah. Okay. Wow, it's pretty amazing. All right, and so it must be pretty hard to get any kind of verbose errors out of this, right? I mean, you don't want to obviously have that open to the world. So if you were trying to get rid of error conditions or anything like that, it's probably pretty hard to enable that in GraphQL.
So I would say more than half of the GraphQL endpoints that I've tested, just sending it garbage as a field will trigger some kind of verbose error. You can also pass a URL parameter in before the query, which is debug equals 1. And some GraphQL server implementations have this as a debug mode, and it will by default send back like full stack traces and stuff like that. So if they don't have that disabled in their production environment by accident, you may be able to just pass debug equals 1, and it's going to send back everything.
Oh, fun.
Okay.
Like what?
I said, oh, fun.
Oh, yeah. Okay. Yeah.
Yeah.
What kind of information are you getting when you add verbose errors? I mean,
typically
is
it's
it
a
information
stack trace.
disclosure? Oh, okay. All right.
Yeah.
Which, information disclosure is kind of a not good thing.
Right.
So, let me see. Implementation errors. You're talking about, delegating authorization logic to business logic layer. We've already talked about that a little bit. Only authors can see their drafts. Some of the vulns in the wild. So Ms. Berlin obviously kind of spilled the beans about the beer stuff. No, that's okay.
I skipped ahead.
Spilled the beer.
Yeah, spilled the beer. Right. So HackerOne has so somebody at Shopify Cloud, I guess, had a bug bounty program through HackerOne, and this was apparently in scope. So somebody got $802 to do something.
It was two testers. So what they did was they basically used WFuzz to try and enumerate some Shopify Cloud.com subdomains, and they found that there was one called beerify.shopifycloud.com. So they realized that this was a GraphQL endpoint, and they sent an introspection query, and they got a response back. And that introspection query listed all of the different office locations as some of the results. So from there, they started pivoting to sending queries to find out more information about each office location. And the information they got back was how much beer was left in the kegs at that particular office. So this was during a bug bounty contest that they were having. So they submitted the disclosure to them under the guise of, while this isn't necessarily a dangerous vulnerability, we could use it to know what kind of beer is your favorite and send you beer to bribe you into letting us win the prize. It was all in good fun. So as a reward, they rewarded each tester with enough cash to buy themselves 3 kegs of their favorite beer.
Oh, nice.
Yeah.
Okay. And so this was supposed to be an internally facing?
Correct.
Okay.
Yeah.
And it was exposed to the internet.
And it was exposed publicly to the internet. And that's a perfect example of how it's just it was an accident, right? They along the way, they have, all these complex architectures, a lot of people with hands in the pie kind of trying to figure out how we want to set up all this stuff. And I guess somewhere along the way, they didn't whitelist the IP addresses. Maybe it was just easier because they have offices all over the place than whitelisting all these IPs and this and that. Somehow it fell through the cracks. This is how these things happen.
Right. And, it goes all the way from, knowing how much beer's in the office all the way up to, migration
knowing all the users
problems
in your database.
Right. So let me see this one from, where's it at? HackerOne itself had a vulnerability in their own GraphQL implementation.
Yep. They've had a few.
Huh. So they're using GraphQL in a Ruby implementation. Does it matter what language you use? Is it language agnostic?
So as of now, there's a GraphQL implementation library for pretty much every programming language out there. That's mainstream. In that particular case, they were migrating to a different class-based API, and I think this story is interesting because it highlights how not having a thorough testing program in place, things can really fall through the cracks. So as they were previous to the migration, they had a field called edges. And within that field of edges, there was a field called nodes. And that nodes was, all set up correctly, had all the authorization logic in place. After they migrated to this new system, there was a field called nodes at the root level, and everyone just kind of assumed that, this is just a shortcut so that we don't have to write our queries in a way to access edges and then into nodes. And it just kind of floated past all the different checks that were in place. Well, come to find out, since this field was at the root level, it just completely bypassed all authorization logic in there.
Oh, wow. Okay. Huh.
Yeah, so they got a $20,000 payout for that one, which is pretty good.
Yeah, that is pretty good.
Really good.
That's not bad for a couple hours work. Yeah.
Yeah, right? That's a lot of kegs.
That's true. So what you said, it was a shortcut down to the edges.nodes or edges nodes area.
Well, they assumed that it was.
They assumed that it was, right.
Uh-huh.
So this nodes was sitting at the very root level, and
correct.
This was above where the application logic was, and that's what I'm understanding.
So it's in the schema,
right?
So it's not that it was above where the application logic was. There was just no application logic designated to filter what was coming through that particular endpoint, and this was built into the Ruby library by default. So this is just one of the fields included in that. Somebody apparently missed reading the documentation of what this field actually did. Some assumptions were made, things were missed. $20,000.
Wow. Okay. Yeah. So we've gone through this. We're talking about abusing the GraphQL. We talked about finding the endpoints using WFuzz or Dirtbuster or what have you. Using the introspection for evil, you get all your available queries. What are you've got mutations in here several times. What is a mutation, and is it different than a query?
Sure. Yeah. So in GraphQL, you basically have three types of requests that you can make. You can make a query request, which you're going to get data. You're going to send a mutation request, and you're going to basically put data. Mutations are the equivalent of, hey, I want to write this new information to the database somewhere. So I'm going to mutate the data that's there with this new information in it.
Okay.
It's pretty rare to find a publicly available API out there that has mutations available for you without any type of logging in. People just don't like you writing arbitrary data to their databases. totally understand.
Sure.
I wouldn't either. But the functionality has to exist to be able to update, and that's GraphQL's way of doing that.
Okay,
Subscriptions would be the final thing, and that's kind of like I can send a query, and it's going to open up like kind of a WebSocket type tunnel, and anytime the information that got returned to me changes on the back end, it kind of has a listener. It automatically sends me that updated data. So I'm subscribing to a query in that case.
I see. Okay. And so you have gets, puts, and mutations, which is change existing data, and puts would be like adding new lines to a database.
So which would still be a mutation. Right?
Okay.
Anytime I'm going to update the database in the back and not just retrieve data, it's going to fall into a mutation.
Oh, all right. All right. So, okay. Go ahead, Ms. Berlin.
Yeah.
Interesting. All right. So, it seems like we need to figure out how to defend against this stuff. If we're a security person, a blue teamer, and we're working in a dev-heavy environment, DevOps with all the CIs and the CDs and the Jenkinses and stuff, how do we protect ourselves, or how do we protect the developers from, sending out $20,000 worth of beer to people?
Right. So, for one, don't turn on introspection responses unless you absolutely need to have them. If you have a SaaS product and your whole deal is having people integrate with your GraphQL API, then it makes sense to have it on. But let's say you're like building a SIEM solution and you don't necessarily have a publicly exposed API out there like that, and the only real interaction to your GraphQL endpoint is going to be from logged in users in their browser session. You probably don't want to have that available. While it's not necessarily horrible to have it, it does give me as an attacker a huge insight into the available attack surface that you're exposing there. So it lets me basically know, it gives me a map that I can use to write tons of different queries or mutations and send them to your endpoint to see if they're successful or not. And if they're successful, then I'm going to take those and I'm going to put them into Burp Intruder and start sending you all kinds of funny data to see if I can trigger something to happen.
Okay.
You said there was no real scanning tools or anything for this, right? Yet?
So I wrote one.
Okay.
Yeah, right. So I wrote a tool called Shapeshifter, and what it basically does is you can pass it in a domain name, and it will search and try and locate the see if there's a GraphQL endpoint available and see if there's a console. It's going to list them out for you, and then from there, if it does find a GraphQL endpoint, it's going to send it an introspection query that's going to retrieve the entire schema for you, and then it's going to parse through that schema for you and locate and build all the different queries that most of them anyway, still working on it. It's alpha. But it builds a whole bunch of different queries based on that schema, and then you can also pass it in a flag for a proxy. So in that, let's say Burp Suite. So once it builds all of these schemas or all of these queries for you, it's going to dump them out into files so you can come back later and manually inspect them. But it's also going to try and send all the requests for them. So you're going to have all these requests being automatically sent in your Burp Suite there, and it listens for the response to them. And one interesting thing that GraphQL does that I've never seen another API do is it has this really handy feature called for suggestions. So if I send it a query for an object or a field that's close to the name of an object or a field that it has in there, but isn't exactly the same, it will actually suggest. It'll be like, you can't query on field XYZ, but why don't you try field ZYX or WPQ or, and it'll give me a bunch of options back that are valid fields to query for. So then Shapeshifter will, if it gets one of these suggestions back, it'll rewrite the query on the fly since it failed at using one of the suggestions until it gets a 200 response for it. So what you get in the end in your Burp tool there, you'll see a whole bunch of queries sent, and you can basically just filter. It's like, show me all the ones that are 200s. So now you have a whole bunch of working queries already written for you in there. And then you can like send in the repeater or intruder and all your other tools start fuzzing and doing all of that stuff. So it really saves you a whole bunch of manual labor of having to parse through an 80,000 line introspection response and manually build up all of these queries with all of the different types of fields in there, and having to, make sure that I'm sending it the right type. Shapeshifter will detect the scalar type of that it's expecting from the schema and automatically generate a argument of that type to fill in for you. It also includes there's a bunch of libraries out there that let people introduce or use custom scalar types pre-written. So I went through and wrote some functions that generate values fitting all of those custom types also. So it has a huge library of value generation functionality to try and generate dummy data to stuff into the queries for you.
Can you remove the helpfulness from your GraphQL so that you don't get, hey, would you like to, try this instead of 15 other things? You can remove that? So
this may have changed, but from when I was doing my research, I found some forums of people asking that, and it's not such an easy thing to do. This is just, there's no like set my environment variable to suggestions equals false or anything like that I know of.
Great. So
right.
Thank you, developer and creators, for being so damn helpful to the bad guys.
And that's the double-edged sword of it, right? It wants to be helpful because it's not intended to be used by bad guys, except it does get used by bad guys. So that helpfulness can be used against it.
If you're calling an API, you're doing that fairly automatically, right? Or it's a mechanical process. So APIs wouldn't know normally that these are, you didn't call this correctly. You would just get some kind of error message, right? In your logs.
It's going to be like a 400 or something like that, bad request, or you're going to get a stack trace maybe, or you're going to get a GraphQL specific error message.
Right. It just seems like that this error message bit doesn't need to be added, maybe only on an IDE or something like that. If there was a way to restrict this only to when somebody's using a console or something like that, would be a lot better. Can you make the error message or a category that you could say, okay, only authorized or authenticated users will gain access to that?
I mean, it's all about how you write your resolver functions, but generally you never want to pass stack trace or verbose error messages back to the client, regardless of the type of API you're using, right? So that's just general security and best practices. We're going to catch those error messages and resolve them to a generic error message and send that back to the client. But these things get missed. Okay.
All right. So devs, don't be helpful. Remove this stuff so that it doesn't show up in somebody's web logs or anything like that. So let me see what else. Check subdomains. So it does seem like that there's a lot more work when you don't have the introspection, but you're just, eventually they will work out the schema, right? With or without test introspection.
So the workflow without introspection is it's pretty close to if you do have introspection, except there's some more steps that you have to take.
Right.
And what I'm going to basically do is the traditional approach. I'm going to get my browser up, fire up Burp Suite, proxy all the way through, click on everything on the website, and I'm just trying to trigger as many queries as possible so that I can look at the queries and responses and try and extrapolate that information from that, what their schema maybe looks like. So another interesting particularly in this case is I don't know the schema that I'm dealing with since introspection is off. So I'm going to take a legit query that I've captured in Burp Suite, and I'm going to do what I like to call parameter stuffing or field stuffing. So I'm going to basically, let's say I have hero and let's say I have user and I want to get the name back. well, in addition to the name field, I'm going to start requesting all kinds of other fields and see if it responds with something. So in the past, I've actually requested the field password and actually gotten hashed passwords back from a database, because however they've written the resolver function, it's just it's somehow mapping. They probably thought that it was really clever, and they were just like, I'm just going to take this field and then map it to the database column name, and we're good to go. So that happens, and so you can just start guessing all kinds of different fields, and you can use wfuzz or intruder with a nice word list, and just start sending the same or repeater and just sending the same thing over and over again, substituting different field names in there to see what you get back.
So you mentioned that this is vulnerable to SQL injection. Could it be also vulnerable to blind SQL injection, where maybe it would take longer, like time-based, or? You can. So a feature that I'm implementing right now in Shapeshifter is to, once it gathers up a bunch of requests that our knows are good with 200 requests, it's going to write those queries out to individual files. And it's going to substitute a custom injection marker along with the generated payload for that particular scalar type that it's expecting for. So then you'll just be able to take SQL map and feed it these queries, and it's going to detect that custom injection marker and try all the different kind of SQL injections. And as far as it knows, these are just legit. These are just like any other request now. Very nice. Okay. All right. Wow. That's great. Especially SQL map. Again, everything old is new again. So you're just using it in a different way. So that's fantastic. Let me see. Ms. Berlin, do you have any questions or anything that, from a logging point of view, this must be a nightmare for you, because, getting verbose logs could, especially if somebody's dumping schemas, it could be 80,000 lines in an error message or something, right?
Oh yeah. That happens a lot.
Yeah. Oh, and if you're logging requests and responses, then I could just send you a metric shit ton of introspection queries, and you're just get tons of 85,000 line responses.
Which is funny about when you go into creating your own sim, you don't think about that stuff until it happens.
Right. Right. I'm sure there's a lot you don't think about when creating.
Oh my gosh. Yeah. Oh yes. But now there's checks and balances for that kind of stuff too. So.
Right. I'll leave sim creation up to the experts.
I'm no expert, but thanks. I'll do it anyways.
That was your chance.
Right. Time to plug the product.
Right.
Yep. So some of the other things you mentioned about protecting GraphQL: do security-focused code reviews, obviously, and training your devs for secure coding skills. What would be some of the quick wins in regards to secure coding? Would it just be making sure that they're doing input validation correctly, or that they're reviewing their schemas to make sure that they don't end up with resource exhaustion kind of errors or authorization errors? What are we looking at there?
Yeah, I think a lot of it is taking the time to really understand the technology that you're working with, and the infrastructure that backs it up, because a lot of these vulnerabilities are nuanced and specific to particular types of code libraries that you're using, and this and that. So really understanding, this is how GraphQL works. This is where I'm supposed to implement my authorization and authentication layer. This is the best practice for doing it. This is where I'm supposed to implement my, input validation and sanitization, and still following all the best practices of using parameterized queries, things like that. And, don't send verbose error logs back to the client. All the basics that we've been trying to do since the internet still apply here. We just have to apply them in a different layer than we would in a traditional REST architecture.
And I would imagine other things like making sure you don't leave API keys or anything sensitive inside there. Hence the
Sure.
the
Yeah,
parameterized queries or
secrets in
prepared
code,
statements.
especially in the case of sending error logs or stack traces back up, a lot of times stack traces contain a snippet of the code where the error happened. So you may be able to glean, an API key from that. So creds in code bad. Don't do it.
Right.
Use a secure, storage and runtime injection, all that good stuff.
Nice. And you say well-tested solutions exist. Something called GraphQL Shield. Is this
Right.
just another layer of it says abstraction layer on GraphQL server permissions? What does that do?
So it's a library that you could use to do authorization authentication, right? So don't roll your own stuff. Lots of bugs have been identified in this particular project and fixed, I'm sure. So it's going to be more solid than what you have. But find something, do your research, understand the tools that you're working with, understand the technologies, understand the libraries and the nuances of how they work. For instance, that Ruby implementation. So really understand the libraries and how they should be implemented and what's actually going on under the hood there. And don't just go into it blind, because that's how mistakes happen.
Okay. So yeah, I'm looking at this. It's fairly easy to install. You just use yet another package manager called Yarn to install. It's based on something called GraphQL middleware. And it says just add permissions to your Yoga middleware set and you're ready to go. And it's compatible with all GraphQL servers. Okay. Cool. Yeah, if you're a developer and you know what that means, shake your head. Otherwise, I have no idea what any of that means. I don't know what Yoga is and whatever that is. So, cool. Okay. Yeah, I'm looking through this. It's very, very interesting. Okay. I've got that link in the show notes to the GraphQL Shield in case your org is using that. You can go to breakingsecurity.com and get the links to a lot of this stuff. So before we started recording, you said that you had actually found a few things after the talk that you were wanting to investigate. Could you maybe expound a little bit upon that, like finding GraphQL in places they didn't expect it?
Sure. Yeah. So one of the interesting things that I found is that Magento 2 has a GraphQL implementation in their code base, and it's enabled by default. So if you find a Magento 2 website out there and you tack on a /GraphQL, you have access to that GraphQL schema. So there's a lot of complexity in there. If you read the documentation, they talk about how it's a very complex system of validation logic and this and that. So that's definitely something I want to dig into and see if I can help them out and find any bugs in that particular system. But being that it's such a widely used e-commerce framework, I would personally, less is more, right? So why not just have it off by default? People probably don't even know this is on. They go through the installation. This is fairly easy to use framework for e-commerce. So there's a lot of people that aren't extremely tech savvy. They're spinning up a Magento 2 store. They install a theme. They put all their products in. They throw it up on a website somewhere, and they may not even understand what GraphQL is, or yet that it's enabled by default in their store. So
right. Yeah, it's actually I just did a search for Magento and GraphQL, and they do have it in their documentation. They do talk about if you run a REST call such as get/v1/products/:sku, which is the product number or whatever, it may fetch more than 100 lines of data. All you need is current price. The calls return significantly more information. With GraphQL, you could run a query against that SKU and return just that price. So
right. So that's a thing about GraphQL is there is no equivalent to let's say like select star. I can't say give me this hero ID and give me all the information that you have about it. You have to be very specific about defining the fields explicitly that you want returned to you. So this is called overfetching. And a lot of times when people are building dashboards, they have to work fast. They're under pressure. So they're like, you know what, just give me all of the data about this particular object, and I'm going to parse through it on the front end and use what I need to, and the rest can just sit there unused. So with GraphQL, you can't do that. You have to actually explicitly define, which is a huge issue if they have introspection as a pen tester. If they have introspection disabled, I can't just say, hey, I found this particular object. I'm just going to ask for all the information about that. I actually need to know the fields in there available to me. And if there's no schema to do that, that's where field stuffing comes in handy to kind of automate that kind of discovery.
Yeah. Yeah, I'm just looking through some of their document. They got a lot of documentation online, even if they don't have introspection running. I mean, there's a lot of information inside, like they're showing requests and responses about how to set up things like, set payment method on carts mutation. They have set billing and shipping addresses. So, I mean, they have the exact methods on how you're going to do those things and query those things. So if you've got a cart ID, for instance, and they show the cart ID type in there, so you know exactly what to query for with regards to the formatting of that and how many characters it might be, and if it's alphanumeric or if it has special characters or whatever. So you could definitely potentially, it would take you a long time, obviously, but alphanumerics, upper lower numbers, it looks like, to do IDOR, you could run through some potential cart IDs and look for that. It would take a while. Would you put rate limiting on there for like brute forcing?
Sure. Yeah, you could. So I don't want to allude to there's definitely something wrong with their particular implementation. I haven't personally had the chance to take the time to test it yet. It's definitely on my to-do list. It's pretty high on there. But I think that the real kind of thing to discuss is it's enabled by default. So I don't know if you've ever had to update a Magento website, but it's not easy. And a lot of times people don't do it because it's such a pain, especially like small, medium-sized businesses. So let's say there is a vulnerability in some particular version of their GraphQL implementation. They need to push out a fix for it. People, one, may not know they even have GraphQL, or what it is. They don't know that it's enabled. Now there could be a potential vulnerability out there that they could fall victim to, and they think they're safe. They're like, well, we're not using whatever this is, right?
Right.
So little do they know that they would actually be vulnerable to that. So I like to try and err on the side with things like this of, let's turn it on. Instead of having everything on in the first place, let's have it off, and you enable the things that you do want.
Right. Yeah, that makes a lot of sense there. That's very, very sensible, control, sensible security control.
Right. Because now you essentially have this unknown attack surface sitting out there. Vulnerable or not, it exists. Yep.
Wow. Wow, we're super over. But this is, I'm learning a lot here. And you're right. The Magento stuff, there may not be vulnerabilities in it, but it sounds like it's the WordPress of e-commerce sites. So
yeah, that's that's pretty much what it is. Yeah.
Oh, well, that's not a compliment, is it? So do they have a bug bounty program? Because it might be something somebody can make, some beer money on or something.
Yeah, so it's open source. I'm sure they'd be happy for you to make a pull request. I'm not sure that they would pay you for it.
Oh.
But I could be wrong. Don't quote me on it.
Yeah. Okay. All right. Well, so you have a tool called Shapeshifter, and there was another one you mentioned in the slides called, what was it?
Yeah, that's a friend of mine, Mike Hodges, wrote a tool called Hide and Sneak. Hide and Sneak. So
Sneak. Okay.
Yeah, so it allows you to basically from the command line spin up a cloud infrastructure in a bunch of different hosts and you install tooling on the infrastructure in a pretty automated fashion. And one of the things it allows you to do is called domain fronting. So domain fronting is basically using a CDN and proxying requests from your attack tooling through the CDN provider. So it looks like these requests or these attacks are coming from there to kind of obfuscate your attack. So if they're whitelisting, doing IP whitelisting based on, brute force attempts, these types of things, a lot of malicious requests coming from a particular location, this is a way to bypass that. And Shapeshifter works really well sitting behind his tool like that to have kind of, your attack chain.
Mm-hmm. And if you're using multiple CDNs, then you're getting around the rate limiting that you would get if you have to brute force your introspection.
Yep.
So,
and usually they don't want to whitelist like Google CDN, or they don't want to blacklist, Google CDN. So it allows you to kind of do some sneaky stuff.
See, y'all are using the kindness of others to get around stuff that hurts their feelings.
That's what we do.
My defense is harder.
I want to go in and be able to block, not GitHub, what is it, Akamai, but there goes my business. So I can't protect against it. What would be okay? So since we can't block all the CDNs in the world, what will we do to protect against that?
You're asking the wrong guy.
No,
we suggest blocking all DigitalOcean.
You can't create the problem and not have a solution.
But that's what I do. That's my job.
No, it's not.
Yeah, I'm bringing the problem to light so other people much smarter than me can find a solution.
Oh, I see. Okay. Well, that makes sense, I guess. All right. So you're going to be at Texas Cyber Summit.
Yep.
How would people contact you and maybe discuss if they wanted to add to Shapeshifter, or if they wanted to, pick your brain a bit more on defense techniques? Because apparently you've already got all the attack techniques down. But how would they get a hold of you if they wanted to do so?
Sure. You can find me on Twitter at RVRSHELL, or just I'll be speaking there, so feel free to come up to me after my talk, and we can chit chat and exchange information and talk about fun security stuff.
Fantastic. Yeah, I after your talk, I felt all weird and got all sweaty in weird places, and I knew that I needed to go up and talk to you because I wanted to do that, but I was like, I don't know if he'll want to come on the show or whatever. And I was like, nope, the worst thing he can say is no. So went up, said hey, and I appreciate you coming on. And
sure, it was my pleasure, man. I've been really excited about this. I've never done a podcast before. I was really shocked that I was invited. So the pleasure's all mine.
We don't have a rock star mentality here. Anybody. We always say that anybody can be on the show.
I don't know if I should take that as a compliment or not, but thank you.
They let me on every week. So
right.
I think you messed up McAfee ever being on the show.
Oh yeah, John McAfee will probably. Yeah, probably not John McAfee. Yeah, if you've heard the pizza party that we did at DerbyCon, he's probably not high on the list. So I would love. Are you planning on giving the talk after Texas Cyber Summit? Because I know B-Side Seattle is coming up, and there's a lot of web-based companies up here that may or may not use GraphQL.
I would be willing to give the talk anywhere. I really want to spread awareness about this, and
right.
There's vulnerabilities out there. There's a lot of untested attack surface because it just hasn't been discovered. People don't necessarily know what they're looking at for a lot of times. So I'm willing to talk about it anywhere, including this show.
Yeah, right on. Let me see if B-Side Seattle has a CFP out yet. I know that we're having one in it's like February or something.
Gotcha.
So,
Texas Cyber Summit is the last one that I have scheduled currently.
Yeah. Okay, cool. I don't see anything in here yet. So I do know we had to move it last year to a week or so because of the weather. But B-Side Seattle, there's a ton of web application development folks up here. Because that's, it's Seattle.
You're right.
Yeah. Yeah. And, it's lovely in the wintertime. So you should come up and visit. So, cool. All right. Well, Miss Berlin, you went to DefenCon. You were at Derby. The villages were phenomenally well done. You did a panel at DerbyCon, which I was front row to see. You did 2 panels. Yeah. Oh, what was the second one?
The first one was the keynote one, and then the second one was the mistakes that we wish our users would stop making.
Right. I saw that one. That one was really good. You had Miss Hacks in there, and it was some dude. I don't know what his name was. Actually, I actually don't remember what his name was.
His name's Lee Neely. He does stuff with Security Weekly.
Oh, okay. Yeah, and there was Miss Hacks, and who were the other ladies on there? Or people on there?
That was a long time ago. You can't ask me to remember that.
You've slept since then. Okay.
Oh, April
it was literally weeks ago.
That's true.
I've been busy. April Wright was on there, and then
that's right. Yes.
Lee's wife, Chanel.
Oh, okay. Yes, I do remember that there was some kind of like connection between the moderator and one of the people on the panel. So cool. All right. Yes, I learned a lot from that one too, because there were definitely some things that we wish that our customers and users would do. I was front row for that one. That was a really good panel as well. I only saw a handful of talks, unfortunately. That's why I'm having all the people on the podcast, so that I can like bug them and ask them questions.
Yes, thank you, because I saw none.
No, I can understand that. So your village, you're doing Hackers Health is on Twitter, correct?
Yes.
And what other ways can they get a hold of you?
Personal Twitter at Infosister, INFOSYSTIR. And then the next physical conference I will be at is GraphQL, end of October.
End of October, okay. All right. And before we started talking, you said Miss Megan, who I saw in Meetspace at DerbyCon and at DefenCon. Yes. She's going to be at the Texas Cyber Summit doing a village as well.
Correct.
Okay. And awesome. That's great. So we're both also active on Slack. The Brakesec Slack has almost 2,000 people, and we have a number of things going on there, including Matt. You might want to come on. We have a web app sec channel.
Yeah, I'll definitely join that.
We have a bunch of different channels. It's very, I wouldn't say noob friendly because we're all noobs there, but it's very friendly to people. We have a social contract. So if RVR Shell would like to join us, he can send us a DM on Twitter or send us an email to bds.podcast@gmail.com. Don't worry, your invite's incoming, sir. But yeah, we have a book club. I think we just did. Oh crap! Which one did we just do? I think it was the Cuckoo's Egg. I think we just finished up that one. Oh no, Attacking Network Protocols is the one that we're doing right now on the European Book Club, because we have one in the Asian European region. We also have a U.S. book club, which meets James Forshaw's book, Attacking Network Protocols, as part of our summer series. And we'll be trying to pick another one very soon. I think we've got Dave Sybuck and JB going through that. There are some of our moderators as well. PonySec is running our CTF club. He just ran, we actually uploaded a video of him last week on doing HTTP smuggling, which I found quite interesting and innovative. You can nest another HTTP request inside an existing one, and load balancers will see the first one and bypass the one in the inside, and actually can cause all kinds of issues. So yeah, HTTP smuggling is very, very interesting attack. Yeah,
you got to play with that content length header.
Yep. If you can attack it with the content length, it's pretty awesome. So yeah, we uploaded that to the Brakesec YouTube channel, so you can go and check that out. He runs through that quite a bit, and quite good. And he runs through the Hack the Box stuff as well. So he's got he does weekend CTF clubs, so you can get on and ask questions and run through various either retired boxes, or he'll help you out by asking you some important questions if you've got real questions on legit one unretired hack the box machines. So anyway, now that I've stumbled over that, let's see. Brakesec, official Twitter, the Brakesec podcast is at Brakesec, Brakesec. Mr. Betcher, whose family's doing sports and stuff this time of year. So Tuesday night was volleyball, which he likes to go and be a dad and be a spectator, which I don't fault him on that. You can find him on Twitter at Betcherpwned, BOETTCHERPWNED, and he's also the lead developer and head dude for LogMD, which is a window forensics tool. You can go to log-md.com for more information on that. You can follow me on Twitter, Brian Brake, BRYANBRAKE, and so for those of you who are catching this on Wednesday, the 2nd of October, I do a local CSEC meetup in Seattle called CSEC East, and we're going to be meeting at Black Lodge tomorrow night, which will be 2 October. And if you're interested, you can come by. We're going to have some talks. Daddy Coco Man on our Slack channel is going to be talking about attacking Python 3.8. And Miss Wendy Knox Everett, who works with me at Leviathan, and has also given this talk at DC Sky Talks, is going to be talking about cake and cookies, which is CAIQ and cookies. So it's like how you make sure your policies and procedures and everything are up to snuff, I believe. So if that's not correct, then I'm going to definitely learn something tomorrow night, because I had assumed that's what that is. So Consensus Assessments Initiative Questionnaire. So it's a survey provided by Cloud Security Alliance for cloud consumers and auditors to assess security capabilities of a CSP, or a cloud service provider. So we're going to learn about cloud service providers and Cloud Security Alliance stuff tomorrow night. Sounds great. Looking forward to it. And so we're on all the major podcast providers: iTunes, Google Play Store, TuneIn Radio, iHeartRadio. We found out that leaving reviews is better than gold in many cases. So if you don't want to leave something in the tip jar at our Patreon, which I'll talk about in a second, you can leave us a review, and that gets us more exposure, which gets us higher in the rankings for podcasts when people search for Infosec or podcasts, and you can help us out in that respect. But if you found value in the talk that Matt just gave tonight, which is more time than just the talk that he gave at Derby, so you're actually getting more content than what he talked about originally at Derby.
You can hear it better.
Oh, it's got better audio quality,
you
too.
You can hear it at all.
Yeah. So if you found value in this and you go back to work tomorrow and you go, man, we got GraphQL and we suck. If we need to turn off introspection queries. So, feel free to drop a buck or two into our tip jar there over at Patreon. I'd also like to thank Josh P. and David G. for actually becoming Patreon supporters. So their support helps pay for hosting fees, the Zoom that we're using right now with Matt and Ms. Berlin, and and helps pay for time and effort to get a podcast out and build our community. So appreciate that, David and Josh. That was it for this week on Breaking Down Security. And, check out our TPub store, tpublic.com/user/BDS podcast. You can get a picture of Miss Berlin's face on a t-shirt. We also
I now have that thing. Yeah. I know.
You bought that t-shirt?
My own. It was gifted to me at DerbyCon.
No, really?
Yes. And I now have my own face on a shirt.
Oh, that's kind of recursion, isn't it?
A little bit.
So, we have the podcast t-shirt on there, Miss Berlin's face. You can also grab, if you didn't make it to Infosec Campout 2019, you can also get a t-shirt of that, which will be vintage eventually. So that was it for this week on Breaking Down Security. Thank you again, Matt, for coming on the show. Appreciate it.
My pleasure.
And that was, we'll have a great week. Be nice to one another, especially on Twitter, and especially the current climate we've got in the world today. Take care of yourselves, because you're the only you have, and we'll talk to you again soon.
Bye.
And we're done. Oh my goodness. Woo!
That was really good.
We'll have to make that a two-parter only because of the freaking time. But when I did not realize it was like an hour and 16 minutes, and I was like, oh,
wow.
crap. But
Yeah, neither did I.
That's really solid content. I appreciate that. So,
thanks for having me. I really appreciate it. I've been looking forward to this for a while.
No,
I think it's really. I've been listening to your podcast. I really like the social engineering one that you did a few weeks ago. That was really cool.
Yep.
So yeah.
It's amazing how some of our best podcasts are ones that have nothing to do with information security.
Yeah.
Right.
Or not the typical InfoSec stuff. So, social engineering, we did one on communication and leadership with InfoSec Sherpa. I always go back to the neurodiversity talk we did with Miss Megan. But there's a lot of ones that we do that don't have anything to do with InfoSec people, I hope that people find interesting, but I always love a good, technical discussion about something that, that interests me or interests others, I hope. So,
and that's the thing that we all do have in common is curiosity, right?
That's
like
right.
Regardless of the topic, we all just want to know all the things.
Oh yeah.
Right?
Yeah. That's my problem. It's like, I know a little about everything or a little about a lot, and that actually hurts me, according to my to previous employers or previous people who I've interviewed with. They were like, well, you don't have any one particular thing you do, and I'm like, no. That's why I'm probably a PM now. So
well, there's still a place for you. You work at Leviathan. That's not a bad gig.
That's true. That's very true. So, all right. Well, I'm gonna let y'all go because it's probably getting late for Miss Berlin, and I don't know. You're in North Carolina or something.
Yeah, it's about 11:25 or so here.
Oi. Okay. Yeah. Y'all have a good night. I will try to get this out sometime tomorrow if I can during lunch. And
cool.
Would Red Ventures put this out, or is that something you don't want to do with?
Yeah.
The
so it's weird with them. They're not. Most people don't even know who they are. They try to kind of stay behind the scenes. So I don't really brand it with their stuff too much like that.
Okay, I'll try. We'll keep that on the down low. We'll just mention you by name,
sure,
and then add some funky hashtags and see what we can get.
Sounds great, man.
So, right on. Sounds great. Have a great night, y'all.
All right.
You too.
Talk to you later.
All right.
Bye-bye.
See you later.
Bye.